we know how to now find the derivative using the four-step process. So when is it that the derivative does not exist? Is there a place where we are not differentiable? So we said that a function is not differentiable at x equal a if we can't attain the limit as we get to that point. Well, there are common situations where f prime of a fails to exist. The first one is going to be that the graph of f has a hole or a break at x equal a. So if you look here, let's call this a. We have a hole or a break at x equal a, so we can't find the derivative because the limit wouldn't exist. So we are not differentiable at a. The second one would be where we have a sharp corner at a. So let's call this a for both top and bottom. Notice there's a sharp corner or a cusp. This is also known as a cusp. Anywhere you have sharp corners or cusps, you fail to be differentiable because the limit doesn't exist. And finally, you have a vertical tangent at A. So we'll call that the point A. So this would have a vertical tangent line. Anywhere you have a vertical tangent, you are not differentiable at that point. So we fail to be differentiable if we have a jump or a break, a sharp corner or a cusp, or a vertical tangent. Determine where this function f is non-differentiable, where f prime of x does not exist. So let's list the x values where we are not differentiable. So if I look here, I'm not going to be differentiable at x equal -1 because I have a jump or break. I'm not differentiable at x equal +1 because I have a sharp corner. Same thing at +3, I have a sharp corner. And then at 4, I have a vertical tangent line. So for this particular function, in example 8, I am not differentiable at -1, at 1, at 3, and at 4. Why is that? Again, because at -1, I have a jump or a break, so my limit doesn't exist. At +1, I have that sharp corner. At 3, I have a sharp corner, and at 4, I have a vertical tangent. Where does my derivative not exist if this is my function? Well, how would I find that out? Well, remember piecewise defined functions? They usually behave nicely, but they might have jumps or breaks here at the x value that changes. So what we need to determine is does this guy give us a jump or a break? So how do I find that out? Well, we find the limit from the left and the limit from the right. Well, what's the limit as x approaches 0 from the left of this function? Well, that would be the top equation. So 1 minus 0 squared is 1. Well, what's the limit as x approaches 0 from the right of this function? Well, that's going to be the bottom equation because those are numbers that are bigger than 0. And 2 times 0 is 0. So, given this information, does the limit as x approaches 0 of f of x exist? No, it does not exist. Why? Because we're not going towards the same number, which means that we will have some kind of jump or break in our function. And if we have a jump or a break, we are not differentiable at that x value because that limit as x goes to 0 of f of x does not exist. So if we have a sharp corner, a jump or a break, or a vertical tangent, we are not differentiable at that point.